Welcome to the DIY Honda Garage channel. The DTC P0982 indicates a problem related to the Shift Solenoid Valve D in the Honda CRV model years 2011 to 2016. This error arises due to a short circuit issue in the electrical circuit of the solenoid valve, rather than any mechanical issues within the transmission itself. The Shift Solenoid Valve plays a critical role in the automatic transmission by controlling the flow of transmission fluid to the appropriate gears. Typically located within the transmission, this component is essential for smooth gear shifting and overall vehicle performance. When diagnosing this code, technicians should first consider the electrical aspects, including wiring and connections, rather than focusing solely on mechanical components. It's vital to utilize the Honda Diagnostic System, HDS, to ensure that all relevant data is recorded before proceeding with the repair process. Accurate identification of DTCs and their specific symptoms are key to effective troubleshooting. The diagnostic trouble code P0982 directly references the Shift Solenoid Valve D, which is an integral component in the automatic transmission system of the Honda CRV. This solenoid operates electrically and has a dual function. It controls when the transmission fluid is engaged or disengaged based on the vehicle's speed and shifting patterns. It's vital for allowing seamless transition between gears, enhancing performance and fuel efficiency. The error code indicates a short in the circuit leading to the valve, hinting at an electrical malfunction rather than a component failure. In terms of location, the solenoid is situated within the transmission, often requiring disassembly to access during repairs. Understanding its function and location is critical for technicians faced with this code, especially when considering further diagnostics and potential solutions. Diagnosing DTC P0982 involves identifying possible causes, which predominantly revolve around electrical problems. The most prominent cause is an electrical circuit issue, which may stem from poor connections, damaged wiring, or a short-to-ground condition. A short-to-ground means that the electrical path designed for the shift solenoid is unintentionally connecting to the vehicle's frame, creating a low-resistance path that can disrupt proper function. Additionally, if there are frayed wires or damaged insulation, these can also contribute to electrical failures. Therefore, careful inspection of the associated wiring harness and connectors is essential in the troubleshooting process. Understanding these potential causes can guide technicians in effectively narrowing down the fault and implementing solutions. The presence of DTC P0982 can manifest itself through a variety of symptoms affecting vehicle performance. One of the most noticeable signs is transmission shifting issues, including harsh shifts or the inability to shift gears smoothly. This can significantly impact driving comfort and vehicle control. Additionally, it can trigger the check engine light on the dashboard, alerting the driver to an ongoing problem. Mechanically inclined drivers may also notice irregularities in how their vehicle accelerates or responds when changing gears. Furthermore, during diagnostics, technicians will identify the DTC codes displayed on the Honda Diagnostic System, which can provide further insight into the nature of the issue. Recognizing these symptoms early can prevent more severe transmission problems from developing. The initial step in troubleshooting DTC P0982 involves a thorough verification process. Begin by turning the ignition switch to the on position, ensuring that all electrical systems are activated. The next step is to clear the DTC using the Honda Diagnostic System, HDS, which provides a clean slate for diagnosing current issues without interference from previous codes. Following this, a crucial test drive should be conducted, keeping the vehicle in second gear for a minimum of 1 second. This helps in duplicating the issue and determining if the DTC reappears. Monitoring the system during this phase is critical, as it sets the stage for further investigation based on whether the DTC pops up again. This cautious approach ensures that any underlying issues are identified early on in the process. In the second step of the troubleshooting process, the focus shifts to the operational check of Shift Solenoid Valve D. Using the HDS, select the option for testing this specific valve. While conducting this test, technicians should listen for a distinct clicking sound, which indicates that the solenoid valve is operational and functioning correctly. The presence of this sound verifies that the electrical circuit is intact, suggesting that the problem may not lie within the solenoid itself, but rather in the circuit or other related components. If the clicking sound is absent, this indicates a potential failure in the solenoid or an issue with the electrical supply. Thus, confirming the operational status of the valve at this stage is critical for guiding the subsequent steps in the diagnostic process. Following the operational check of the solenoid, the third troubleshooting step reiterates the importance of verifying the onboard diagnostics (OBD) status. Another test drive should be performed, again in second gear for at least 1 second. This reiteration serves to gather fresh diagnostic data regarding the solenoid status while operating. After this drive, it's essential to monitor the OBD status for the presence of the P0982 code in the DTCs menu. If the HDS indicates that the status is failed, this confirms the issue has been duplicated and other steps are required. However, if it indicates passed, this could suggest the system is functioning adequately at this moment, albeit with potential intermittent issues that require more focused investigation. Collecting this status data provides a clear picture of the electrical circuit health and its components. The fourth troubleshooting step entails a series of checks focused on the internal resistance of Shift Solenoid Valve D. Begin by turning the ignition switch to the lock 0 position to ensure that all electrical systems are powered down. The next step is to use the HDS to jump the SCS line, which is a method used to bypass certain safety features temporarily while conducting tests. Following this, disconnect the PCM connector C, which houses multiple electrical connections, including those for the solenoid. Once disconnected, resistance measurements need to be taken between specific test points. Test point 1 is at PCM connector C, pin number 32, and test point 2 connects to a solid body ground. The result should be checked against a threshold of 13.8 ohms. If the reading is less than this figure, the circuit is likely intact, and further troubleshooting is warranted. This step is essential for checking the integrity of the electrical pathway leading to the solenoid. In the fifth step, the focus turns to assessing the Shift Solenoid wiring harness specifically. First, disconnect the 8-pin connector of the Shift Solenoid to ensure that fault checks are isolated. With this connector removed, continuity must be checked between the same test points as in previous tests. Test point 1 connects back to the same PCM connector C pin described earlier, while test point 2 connects to the body ground. The purpose of this test is to identify if there is continuity indicating a short to ground in the SHD wire, denoting a failure in the wiring. If continuity is present, it confirms that there is a short circuit in the SHD wire, necessitating repairs to the faulty section. Should continuity not exist, it suggests that the wiring is in good condition, leading technicians naturally to the next troubleshooting phase, which will examine the solenoid itself for issues. The sixth and final troubleshooting step requires testing the Shift Solenoid Valve D directly to confirm its operability. Technicians should conduct specific tests to ensure that the solenoid can engage and disengage as needed. Should the solenoid be operational and function as expected, the next action would be to replace the Shift Solenoid wire harness, as it may have undetected faults affecting performance. On the other hand, if the solenoid fails the test, it will require replacement, followed by a thorough repair verification process. This involves reconnecting all components and conducting a final test drive to ensure that the issues have been resolved and the DTC does not reappear. This systematic approach ensures that every aspect of the solenoid system has been addressed before concluding the repair, helping avoid potential complications down the line. Final repair verification is crucial to confirm that the issue causing DTC P0982 has been accurately resolved. After completing repairs, all connectors should be securely reconnected to ensure proper electrical flow. The next step is to start the engine with the shift lever in the park position and allow it to idle for a moment. Usually 1 second will suffice. Following this, a test drive is necessary to validate all repairs. During this drive, monitoring should be conducted to check if the P0982 code reappears. The diagnostic menu on the HDS will indicate whether the OBD status is passed, failed, or not completed. If the status shows passed, the repair process is complete, verifying the effectiveness of the service work performed. Should it show failed, further inspections would be needed to troubleshoot potential remaining issues within the electrical circuits. This comprehensive approach ensures long-term reliability and performance of the transmission system. Preventive maintenance is a vital aspect that can help in avoiding the recurrence of DTC P0982 and similar issues in the future. Regular inspections and checks of the electrical system, including solenoid valve connections, should be part of the routine vehicle maintenance. Ensuring that all wiring is intact and free from frayed edges will help prevent shorts and other electrical failures. It is also beneficial to maintain clean and secure electrical connections to the solenoid valve, which encourages optimal functionality and reduces the risk of intermittent failures. Additionally, keeping the powertrain control module, PCM, updated with the latest software can significantly improve overall system performance and responsiveness. By following these preventive measures, vehicle owners can enhance the longevity and reliability of their Honda CRV transmissions. In conclusion, addressing DTC P0982 requires a comprehensive understanding of the shift solenoid valve's function within the Honda CRV's transmission system. Emphasis has been placed on diagnosing and troubleshooting the underlying electrical issues rather than mechanical failures, underscoring the importance of thorough and methodical workflows. By checking the electrical pathways, monitoring resistance, and ensuring continuity, technicians can accurately identify faults and implement effective repairs. Regular engagement in preventive maintenance practices and updates further enhances reliability. Ultimately, diligent diagnostics not only resolves immediate concerns, but establishes a foundation for long-term vehicle performance, allowing drivers to enjoy a smoother and more reliable driving experience. Please like and subscribe to the channel. See you next time.